So hey everyone, welcome back to Placements Ready. In this video, we will be discussing the problem insert a node in a BST. So we are given a BST and a key k. If k is not present in the BST, insert a new node with a value equal to k into the BST. If k is already present in the BST, don't modify the BST. So basically we are given a key. If that key is already present in the BST, we don't need to do anything. Otherwise, we will need to insert that into the BST. Okay, so let's discuss this problem in more detail. So let's say my BST is like this 2, 1, 3, and let's say my key is 4. So what we can do, first of all, we can check if that is present in BST or not. For that, you can use any traversal. Basically, there are 3 traversal techniques: in order, pre-order, and post-order. One is also a level order. So you can use any of them to check whether that is present in my BST or not. You will get your answer. Let's say if we do a in order traversal, how can we do that? Let's check this. So basically in order traversal, we go to the left child first. So for 2, the left child is going to be 1. So we will compare if 1's data is equal to 4. No, it is not. So we can return from here. Okay, we go to the root node, we compare is 2's data is equal to 4. No. So now we go on to the right child. We will compare if 3 is equal to 4. No. So we return to the root and we return to the parent. Okay. So in order traversal, you travel left child first, then the root, then the right. Okay. So you can do in order traversal to check whether that key is present in the tree or not. If not, what we can do? Let's say this is my tree and my key is going to be 4. One thing you know in BST that for every node, okay, the right subtree will be containing the values greater than that node and the left subtree will be containing the values lesser than that node. What I want to say, let's say if this is a node containing a value x, all the right subtrees, okay, will be containing a value greater than x and left will be containing a value less than x. It can be equal to also. Now we can use this property and solve our problem. So let's see how can we do that. So let's say 2, 3 and 1 and key is going to be 4. Since 4 is greater than 2, I know that has to be inserted in the right part. So we move to right, we come to 3, we compare. Since 4 is also greater than 3, but for 3 we don't have any right child. Okay, so when you don't have anything in the right, what we can do? We can simply make a new node that we can make easily using node star new node is equal to nothing but new node of key. We can pass that and our struct will return me the object and we can assign that to it. So we make a new node with a value 4 and assign that to the right part of that 3. Similarly, let's say for 2, 3 and 1. And let's say my key is going to be -1. We come to 2, we compare the data, key is -1, okay, and the root's value is 2. We know that has to be inserted in the left part. So we come to left. Now we compare these two. Now -1 is going to be lesser than 1. So we know we need to insert that in the left part. Again, we don't find anything. We can simply make a new node and assign that to the left part of the tree. So basically what I want to tell you is that at any point of time, if you get a null, you simply return a new node. Okay. Otherwise, we can call that function recursively and do our job. So how can we write that recursive function? Let's say my function's name is insert. I know we need two things, node star root and key. Now, if at any point of time, if my root is going to be null, what we will do? Make a new node simply. Otherwise, if that is present, you can simply return your root. Okay, no need to do any changes. And let's say if my key is less than equal to root's data, what I want to do here? I know key is less than the root data. I need to insert that key into the left part. So we can call this function recursively and assign that to the left part of the root. So insert, we can pass root left and key. Otherwise, we can simply put that up into the right subtree. Okay, right part and key. and finally we can return our root. So in this way we can solve our problem, and I hope you have understood the explanation. Let's discuss the implementation. So basically this is going to be a present function. Basically it is checking कि हमारा की जो है present है कि नहीं ट्री में. तो अगर रूट हमारा नल होता है मीन्स देर इज नो डेटा प्रेजेंट, वी कैन सिंपली रिटर्न अ फॉल्स. इफ द रूट्स डेटा इज इक्वल टू के, वी कैन सिंपली रिटर्न अ ट्रू. अगर मेरा के बेसिकली जो की है वो रूट के डेटा से कम होता है, मतलब we should search for it in the left part. So we will call the present function on the left part. Otherwise, we can call it on the right part. So it was basically a pre-order traversal. You can use any of them. Now this is the insert function. If my root is going to be null, बेसिकली 3 के केस में क्या था, राइट चाइल्ड कुछ भी नहीं था, तो हमने क्या किया, एक न्यू नोड बना के वहाँ से रिटर्न कर दिया. ठीक है. अगर प्रेजेंट है वो की, वी कैन सिंपली रिटर्न. अदरवाइज अगर की हमारा छोटा होता है रूट के डेटा से, मतलब हमें लेफ्ट पार्ट में इंसर्ट करना है उसे, तो वी कैन कॉल दैट रिकर्शन on the left part of the tree, okay, and otherwise we can call that on the right part. So I hope you have understood the problem, you understood the implementation as well. You can find the link to the solution to C++, Java and Python in the description. If you have any doubts, write it down in the comments. Do like this video and subscribe to my channel for more such videos. Thanks for watching, guys.